math read tomorrow. Also, a couple of things. Tomorrow at 3:20 is the end of getting stuff made up, turned in, late stuff. So if you still have homework to turn in, you haven't taken a quiz or a test, that needs to be done either today after school or tomorrow after school in terms of taking assessments. Homework can be turned in anytime before 3:20 tomorrow. Got it? Okay. One more thing. In office hours starting Wednesday, we're going to start a course doing review for the exam. You will not be participating in office hours unless you have written down, actually physically written down on a piece of notebook paper, the problems that you want to review. Because when you walk in, you're going to hand me those papers and I'm going to let you sit down and join us. If you do not hand me a piece of paper with problems written down, you are not going to participate. Because reviewing is for you and you have to put some time and effort in. You're not going to just walk in and say, do some problems. I'm done with that, not doing it anymore. You've got review problems to work on, you work on them. The ones you don't understand, you'll write down on paper, and that's where we start. Clear? Okay. I'm happy to do whatever problems you write down on that paper. But everybody's got to have some written down. All right, so I'm on this exam review. I don't know, you'll have to go back and see. Number one, find all of the asymptotes. Now notice the word all is underlined because we have vertical and horizontal, right? So who remembers anything about how we proceed with this problem?
Factor.
We have a factor at the bottom. Don't we almost always factor everything, no matter what kind of problem it is? We start out by factoring. Okay, now what? The denominator can't be zero. So that means that my vertical asymptotes are whatever makes this zero. So x is 5 and x is -1. Now those are the actual asymptotes. If you put cannot be's in there, I'm not going to mark that wrong. Those are where the vertical asymptotes are. Now what about the horizontal asymptote? Where does it come from? Jacob? No, that would be to find the x-intercepts. To find that one?
Would be the highest powers of x5.
So we go back to the original problem. The highest power is x squared. How many x squareds do we have on the top? None. So then we box in the highest power, and we have y equals 0 over 1, which is 0. So your horizontal asymptote is y equals 0. So there's all of the asymptotes. All right, number 2, find the remainder. Okay, how do we find a remainder? What does that mean we need to do? We need to divide. And the easiest way to divide would be using synthetic division. I remember this was a test question and some of you weren't careful. When you write this down, make sure that you don't have any zeros in there, right? So we've got our exponents are 3, 2, 1, we're good. We don't need any zeros, but sometimes we do. So be on the lookout for that. Since I'm dividing by x plus 2, I got the -2 in the box. Drop this 2 straight down, and then here we go. Oh my. Oh my, did I do that right?
That's right.
So what's my remainder?
-51.
-51. That number right there is the remainder. Find the y-intercept. Think about when you graph something, isn't the y-intercept like right there? What do we know about that point?
X is 0.
X is 0. Bing, 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 bing. How do we find a y-intercept? We let x be 0. So I'm just gonna plug in 0. What is 0.3 to the 0 power? 1. So I have 28 over 3 plus 4 times 1. What's 3 plus 4 times 1? 7. So my y-intercept is at 4. The y-intercept is always found by letting x equal 0. So I'm looking down here because Michael happens to sit right in front of me. On her paper, she's got written, let x equal 0. That's her little note to remind herself every time you do an x-intercept, or excuse me, a y-intercept, you're gonna let x be 0. All right, solve. Okay. What's step 1?
Factor.
Factor that right there, right? So I'm just gonna go ahead and do that. That's gonna be x plus 1, x plus 2. Step 1, all the problems I can think of, we always start by factoring if we can factor. All right, now what?
Make it common.
Make all of the denominators the same. So this is what the common denominator is. So this one needs an x plus 2. This one needs an x plus 1. And this one doesn't need anything. Once the denominators are all the same, we can drop them. So we basically have x squared plus 2x. This is a distribute. This is a distribute. And that's just 7. So now what?
Combine my terms.
Combine like terms. So x squared, 4x. I'm gonna go ahead and subtract 7. Is that all right with everybody? Because as I was writing this down, I noticed this is going to be an x squared equation, and I need to have it set equal to 0. Now what can I do with it once I get it set equal to 0?
Factor.
Factor it. And how does this one factor? Plus 5 minus 1. So x equals -5 or x equals 1. Do we sometimes get answers that don't work on this kind of problem? Yes. And when we say they don't work, we mean if we put them back in, we get a 0 down here. Now, is there going to be anything wrong with -5 and 1? No, they're both fine. But sometimes we do get extraneous roots with those things. Okay. Find the solution set. In other words, that's just a fancy way of saying solve. Remember, we're required by the school to have questions in common for all the levels. So some of these questions are on the academic test, some of them are on the honors test. You all get tested over some things. So sometimes the wording is a little bit weird. Find the solution set. Solve. Just solve it. Okay, so what do you want to do? Add the 4. Yeah, I would add the 4. And now you're on your own. Do whatever you can remember to do. So what can you remember to do? So Scout wants to make 2 equations, which is the way you did it in algebra, and it's perfectly fine. When you make 2 equations, though, remember that the second equation is equals -6. And as soon as you're making 2 equations, you don't have the absolute value anymore. That's gone. So then you got 3x equals 7, x equals 7/3, 3x equals -5, x equals -5/3. And those are the answers, and those are fine answers. If you do it a different way, which I do because I'm a calculus student, but if I do it a different way, I'm gonna get those same two answers. Scout?
Would it be the same if I multiplied a negative to the 3x minus 1? Would it have the same results instead of doing it to the negative
3x
6?
plus- yes, yes,
Okay.
yes. All right, page 1 done. All right, page 2, we're solving. Okay, this one is definitely an easy way and a hard way to do the problem. They'll both work. I'd rather do it the easy way. So the easy way is, I'm trying to get x by itself, so I'm gonna add 4. But when I add 4, I have to add it to every part of the problem. So now in the middle, I have 3x left. Over here, I have a 2. And over here, I have a 15. Right? Now I'll divide everything by 3. So now I have just x, which is exactly what I wanted, just x, between, well, that's 5, between 2/3 and 5. Now that's the way the answer comes out when you solve it. What would that be in interval notation? Because we always answer in interval notation. It would be a parentheses at 2/3 and a bracket at 5. Because our equal to's are brackets. And not our equal to's are parentheses. Okay? X squared minus 7x plus 4 equals 0. All right, this is easy. We're gonna get this one right. What is that? It's a quadratic equation. How do we solve quadratic equations? Quadratic formula. Now, if you want to factor and they factor, go ahead. This one doesn't factor though, so we're going to need the formula. Is Mrs. Ford going to give us the quadratic formula? No way. You need to know the quadratic formula, okay? I'll give you like PERT and all that stuff, but you need to know the quadratic formula. So, x equals negative b. I'm going to write it down in case you're one of those people that don't know it. You need to write this down and memorize it. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so here we go. Negative b, the opposite of b, plus or minus 49 minus 4 times a times c all over 2a. Listen, we get a lot of mistakes. Is that 49 right there? It's positive. Why is it positive? Because we got it by squaring something. And I don't care if you squared a negative or a positive, it doesn't make any difference. That number will be positive always. I should never see a negative right here because that's a square. All right, here we go. What's under there? 49 minus 16, which is 33. And there are your answers, that's it. There. Sometimes when we do this, we can like break this down or something, but we can't. That is it. All right, what's the domain? Well, what do we know about x? That's a fraction. fraction, the denominator can never be zero. So whatever else is going on, x cannot be -2. If I were graphing that, I'd have a vertical asymptote at -2. Those are cannot be's, is what x can't be. If you think back, there were two things you had to be concerned about in a domain question. The denominator can't be 0, and whatever is under the radical has to be positive.
Positive.
I'm not making this up. That's all part of like chapter 2. This one doesn't have a radical, so I don't need to worry about that, but it does have a denominator. So x plus 2 cannot be 0, so x can't be -2. Right? Now, this is going to be a multiple choice question on the exam. This may be written there, and if it is, if that's choice A, grab it. That's the answer. But, what if that is written, so here's my number line, x can't be -2. But could x be anything else? Yeah. So x can be all of these numbers or all of these numbers. So as an interval, that would look like this. It's everything except -2. So from -infinity to +infinity, except it breaks at -2. There's an opening at -2. This says the same thing as this. Now, when I grade your multiple choice, I'm going to grade your work also. So if you have this written down, but you haven't matched it to this, at least you'll get partial credit because you know what you're doing. Okay? But the answers on the test are going to be intervals, because that's what we're supposed to be doing. All right, number 9. What do I do about this? Quinn, I know you know how to do this one. You did it this morning. You did one just like it this morning. You got a function.
Yeah, put x plus 2 for x's.
So it's x plus 1, I think. But yes, so every x, we're gonna plug in this right here. Make sure you're on the right review sheet. We're on the one that doesn't say number 2. So 3x plus 1 squared minus 2x plus 1 plus 1. So what we do is exactly what he said. Whatever they've given us right here, that gets plugged in for the x's. And now we just start simplifying. So this means a FOIL, right? So x squared plus x plus 1, I'm FOILing. First outside, inside, last. X squared plus 2x plus 1. Now that's this right here. I just did that part. Now what do I need to do?
Foil the other one.
Well, this isn't a FOIL, this is a distribute. So minus 2x minus 2, yep, that's a distribute. It's only a FOIL if it's squared. What do I need to do?
3x squared.
I gotta
plus-
take this 3 times this, don't I? So I'm gonna have 3x squared plus 6x plus 3, and then all the rest of it there. Then what do I do?
Add them all together.
Mhm. Right through. So 3x squared, there's a lot going on here, plus 4x plus 2 look right? You're done. It doesn't say solve. There's no equals 0 or anything like that. Your job was to figure out what happens when you plug x plus 1 into this function. That's what happens right there. Finished. What does number 10 mean?
You're going to do, you're gonna put, x plus 2 into, you're gonna do x squared minus 3x plus 1 times x plus 2.
No. This one is actually just like this one. This one we took x plus 1 and plugged it in for the x's. Here, we're gonna take whatever the g function is. Well, the g function is x plus 2. So we're gonna take x plus 2 and plug it into our f function. This says put g into f. So we're gonna put g, the g function, into f. So we're gonna get x plus 2 squared minus 3x plus 2 plus 1. Put g into f. That's g, so that goes in here and here. All right, what do we do right here? We just did it. FOIL, that's a FOIL. So x plus 2, x plus 2. So collect your like terms. I got x squared plus 4x plus 4. Now we gotta distribute here, so that'll be minus 3x minus 6. And then we'll collect like terms. I don't know, does that look right? That's what I got.
Yeah.
And we're finished with it. We're not solving anything. There's no equal 0 or anything. We're done. We're done with that. Hopefully, this stuff is looking familiar. You may need to go back and study it. But hopefully, there's some jogging some memories there. All right, so now we've got this, and we need to draw a picture of it, and it's no calculator. I've starred the ones that you're allowed to use a calculator on. This is a no calculator problem. All right, here we go. Anybody know what shape we've got here?
Parabola.
It's a parabola. Yes, how do we know?
Squared.
Squared. Very, very good. Now, the normal parabola, the BFF parabola, looks like this, right?
This one's
Well, this one's gonna be upside down because of
negative.
that. And it's not gonna be at the origin anymore. It's gonna be shifted
Right 3.
right 3
Up 1.
and up 1. So right 3, up 1, and upside down. Oh my gosh, how simple is that? And you remembered it very, very good. Okay, everybody got that? Speaking of parabolas, we've got one in number 12. Only it's not in vertex form. This is called vertex form because it tells you where the vertex is. This one you have to find your own vertex. Anybody remember how to do that? I'm not giving you this formula either.
Oh, it's negative.
Negative b over 2a. So to find your vertex, you're gonna use negative b over 2a. Now, that doesn't give you the whole vertex. That gives you only the x. You have to figure out the y. Alright, so here we go. Negative b over 2a, I got 2. So my vertex has an x coordinate of 2. How do I get the y?
Plug in the 2 for
Plug
x.
in the 2. So 3 times 2 squared minus 12 times 2 plus 4. You can do this without a calculator. What's 2 squared times 3? 12. What's 12 times 2? 24 plus 4. Alright, what's 12 minus 24? Negative 12 plus 4 would be negative 8. You're going to have plenty of time for this. We're going kind of quick because I want to get through as much as we can. But remember, you have a full 90 minutes for this, and nobody ever takes 90 minutes on this exam. All right. 13. Write the equation that would result if you applied the following transformations to y equals x squared. So in other words, we're starting with our handy dandy parabola, and we're going to do some things to it. How do we make a horizontal shift to the left 2 units?
Negative.
Parentheses x plus 2 squared.
Add 2, so that would be y equals x plus 2 squared. Doesn't that move us 2 units to the left? We want to have a vertical stretch by a factor of 3, so we want to make it like 3 times as steep. Put a 3 in front of it. That's right, Eli. He said, just put a 3 in front of it. Absolutely. Multiply it by 3. That will make it 3 times as steep. And then we want it to go up 1. Plus 1 on you. There you go, kids. That's it. That's your equation. It's that easy. Remember, left and right goes in the parentheses. Up and down goes outside the parentheses. And anything associated with height, steepness, stretching, shrinking is a multiplier. Use interval notation to list the intervals where the function is increasing. All right, 1, 2, 3, 4. Okay, so we've got a picture that looks like this. Okay, so it looks like this, okay? Would you agree that if you put your pencil right here and started following that line, sometimes it's going up and sometimes it's going down. When it's going up, you are increasing. So let's mark that on our graph. Where are we going up? We're going up from here to here, right? Isn't all that up? And then it's also up here. The intervals that you are writing are x's. So what is this x? Can you tell in the picture? What is that x?
Negative 3.
Negative 3. What is this x? 1. So from negative 3 to 1, and again, the intervals are x's. X's. So from negative 3 to 1, my pencil's going up. Where else is it going up? What's this x value? 3. What's this x value? 4. put a U between them, and there they are. Those are the intervals where we are increasing. You know, there's always multiple versions of everything. So somebody's gonna get an exam that probably has decreasing on it. Isn't it gonna be the same thing? Only we'll be looking at where our pencil is going down. The important thing is, when you write your intervals, X's, that's what the numbers that go inside. All right, here we go. Okay. All right, so we've got X minus 2X minus. Now, I want to forget the vocabulary for a second. We know how to graph this. Who remembers how to graph this? What do we do first? Okay, Jackson's going like this. It's going to be some kind of wavy, curvy thing, right? But what do we need to do to start? Plot points on the x-axis. And where do those come from? They come from the parentheses, right? So I'm going to have a dot at 2 and a dot at 4. Stop right now, right there. Those dots are on the x-axis, right? They're called x-intercepts. So the first question said, find the x-intercepts. You do it all the time. 2, 0, 4, 0. Those are the x-intercepts. Okay? Would you agree that's an x cubed? And x cubes start down here. Now, what do I do when I hit that point right there? Your choices are go through it, bounce off of it. You're gonna go through it, aren't you? What happens when you hit that 4?
Bounce off.
You bounce off. And how do we know we bounce off there?
Square.
Because that factor is squared. Okay, is all this coming back to you? See this point right here? That's called a point of tangency. We didn't use that word because I try to avoid math language as much as I can, but that's a bounce off. We called it a bounce off. The curve is tangent there. Tangent means it just hits and goes on. So when it says, at what point is the curve tangent to the x-axis, that means where is there a bounce off? That is it right there. Now, the only one I don't have is my y-intercept. That would be right here. We don't normally plot that, but we've already discussed it. How do you find a y-intercept? Let x equal 0. So I'll come up here, 0 minus 2, 0 minus 4 squared. I'll just plug in 0. So 0 minus 2 is negative 2. What's 0 minus 4? Squared. 16. What is negative 2 times 16? Negative 32. So your y-intercept is negative 32. There are several y-intercept questions on the exam. No matter what the equation looks like, how do you find a y-intercept? You make x 0, and then just do the math. All right, 16. Find the inverse. So here's our function, and our job is to find the inverse. That's our notation for the inverse. Anybody remember the steps we go through? Oh no, negative 2x minus 5. X equals negative 2y minus 5.
It's this one.
X plus 5 equals negative 2y, and y equals x plus 5 over negative 2. That's your answer. So, there it is, there's our inverse. What are those steps again? What did I do first?
You flip the X and Y.
I made, well, first I remembered that f of x is the same as y. Then I switched my variables, and then I just started doing things to get y by itself, and that's the answer then. So switch your variables and get y by itself. Switch your variables, get y by itself. Maybe you making a note of that on your paper. Kids, you know what? Love me or hate me, you know exactly what's on every test I give you, right? There are no surprises. The exam is the same. If this is on the review sheet, guess what? It's on the exam. So if you don't remember these steps, make a note over to the side so that when you go home and study, because your exam is Thursday, that's not very far away, you'll study this. Okay. Oh my, 17, 18, and 19, these are fresh in our mind. 17, 18, and 19, here we go. Right, ln 8 equals x in exponential form. In other words, loop-de-loo it. Get rid of the logarithm. ln is log base e. Some of you forgot that on the test. You can't forget that. ln is log base e. What does this say when I loop-de-loo it? E to the x equals 8. Done. That's it. You're not solving it. You're not doing anything with it. You're simply rewriting it. Write as a single logarithm. In other words, ln.
ln 3x squared over y.
I hear 3x squared over y. We gotta remember that this guy right here represents an exponent, right? So that's how she got x squared. Why did she multiply the 3 and the x squared, but divide the y? Because a plus means multiply, a minus means divide. She's right. That's it. All right, Abby, let's see if we get one more down correctly. One more. Here we go. What are you going to do with this? This is a solve now. You're going to loop-de-loo it. When do we loop-de-loo? Log equals number. Log equals number. We loop-de-loo. So 4 to the second equals 3x plus 1. 16 equals 3x plus 1.
Minus 1.
15 equals 3x minus 1 from both sides.
Divided by 3.
And x equals 5. You like that problem?
I like that a lot.
I like that a lot. Oh, really? So there's one you like anyhow, right? Okay. Sketch. All right, so this is now a picture you're going to draw. This is like the one we talked about earlier. It's going to be some kind of wavy thing. Well, it's going to be a cube. You know what cubes look like. But what do I need to do first? What do I always do first if I can? Don't we factor if we can? So take a look at this. Does this factor?
You can take out that.
Take an X out. Really good, Jackson. Take an X out. Always take out a GCF if you can.
Difference of squares.
And then what do you know? Eli, quit touching him. Pay attention.
Sorry.
What can we do with this guy?
Difference of squares.
X plus 3, x minus 3. Now we go to our picture, and I'm gonna put some dots, some x-intercepts on my number one, on my axis. Where are the dots gonna go? 0, 3, and 3, right? Remember, if you have a plain x, that's a 0. Now, this is an x cubed, we already talked about it. X cubed start down here, right? Every time they hit a dot, they have a choice. They either are tangent, bounce off, or they go right on through. What are we doing when we hit -3? Okay, wait. When do we bounce?
Square.
Are any of these factors squared?
There's no bounces.
There's no bouncing happening. So we're gonna go through it, go through it, go through it. And there's your picture. And that was your job, sketch it. Okay? List the PRRs, possible rational roots. List the PRRs. So that would be factors of 6. What are the factors of 6?
1, 2, 3, and 6.
1, 2, 3, and 6.
Plus or minus.
Over the factors of 3, which are 3 and 1. PRRs are factors of last over factors of first. Now, when I list these, I have to do every combination. So I like to do one group at a time. So 1 over 1, 2 over 1, 3 over 1, 6 over 1. Well, isn't that just 1, 2, 3, and 6? If they're over 1? But what if they're over 3? Well, then I have 1 over 3, 2 over 3. Now, 3 over 3 is 1, and I already have it. 6 over 3 is 2, and I already have it. So there's my list.
Where did the 3 come from in the denominator?
Factors of last over factors of first.
Yeah.
Right? So those are my PRRs. Find the roots. What do? I start guessing. And I wouldn't start with the fractions. You can if you want, but I wouldn't. I would start with nice numbers, like maybe 1. So let's try 1. I hope it's the right one, but I'm not as lucky as you, right? Oh, I was this time. So one of my answers is 1. All right, where do I go from here? So I got to answer blank, 1.
3x squared minus.
Then I look at what's left. 3x squared minus 3x minus 6. And I need to solve that. Well, first of all, can I divide out a 3?
Yep.
So let's do that. Because it looks a lot easier when I do that, right? Dividing everything by 3. Now, what do I do with that? If it factors, I can factor it. What else can I always do? Quadratic formula. So whatever works for you, I think that does factor. So what did the question say? Find all the roots? So 1 was the one I guessed, and then I have -1 and +2.
And 1.
Yeah, 1 was the original one I had. Is it good to have 3 answers to this problem?
Yes.
Yeah, it's an x cubed. Wouldn't it have 3 dots if I graphed it? All right, number 22, you can't see it because my copy was crooked, but it has a star next to it. So this is a calculator problem, and it is like one on your test you just took. E to the 3x minus 1 equals 5, which by the way, those tests were overall quite good. Quite good. ln both sides. Normally, we divide first, but there's nothing to divide. So we're gonna just jump in and ln both sides. And then what happens right here?
E cancels out.
So 3x minus 1 equals ln 5. Now ln 5 is a number. So to get x by itself, aren't I gonna add 1 over here? And divide by 3. So ln 5 plus 1 and then divided by 3. Now keep in mind, the 5 is in parentheses. So ln 5, close parentheses, plus 1 equals divided by 3. Make sure you are getting 0.8698 as your answer. Type it in again if you didn't. ln 5, close parentheses, plus 1 equals divided by 3. Everybody get that? To the nearest dollar, how much would you have if you invested this much money at this much interest, compounded yearly for 10 years? All right, which formula is that? Yeah, the long one, so that's this one. And we know that because it says compounded weekly, right? How much would you have? These are our favorites. Nobody missed these on the test. They missed the other ones, but not this one, because this one's easy. Plug it in. You invested $12,000. Some of you are getting the interest rate wrong though. What do I put in? It isn't 3.5.
0.035.
0.035. You gotta move that decimal point 2 places. And we're doing it weekly. So 52 is your N. And we're doing it for 10 years. So times 10 up here. 520. Please take a good look at that and make sure you understand why the numbers are going in where they are. 12,000, parentheses, 1 plus 0.035 divided by 52, close parentheses, raised to the 520. I got it. Now it says, and again, remember, there are like 5 teachers involved in writing this, so we have to kind of be flexible. It says to the nearest dollar, which means we're going to round off to the dollar. So we do $17,027 because it's actually $26.81. So to the nearest dollar, it would be $17.27.
Whoa.
I think it was 3 point, wait.
Dude, why are there E's in my answer? What do you see?
Oh, shut up.
It's a matter of Calgary and say.
I just put in a different number, but it came out virtually the same, so that's why I'm just sticking
Okay,
with
but
this.
virtually the same isn't good enough.
I know.
This is the answer.
That's what came out. It came out 17,026.94.
Okay, that's wrong. So I'm
I
not sure
know,
why
yeah.
I have it.
It works.
Okay. All right, here we go. Next one. We're not gonna finish this one, but we'll finish it tomorrow, the next time I see you. Number 24. Find the growth constant for a strain of bacteria, da, 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 da. What formula? All right. 1025 is what I end with. Remember, this formula starts with the end here. This is the end. The beginning is 386. I don't know the R, but I know 3.8 hours is my time.
Divide by 380.
Divide, this is one where I'm going to have to divide first. Okay. And then
ln both sides.
ln both sides. And the ln stays over here. Some of you guys are cancel stuff out, crazy. That doesn't go anywhere, that stays. This cancels and leaves you with 3.8R.
Divide by 3.8.
So we're just gonna divide by 3.8 and round it to the nearest thousand. So ln 1025 divided by 386. Then divided by 3.8. I got to the nearest thousand, 0.257, that's an easy one. Anybody else get that? All right, one more. We're gonna fly through this one. Everybody can do this. How do we write the equation of a line? Find the slope. How do you find the slope?
Y minus y over x minus x.
So 11 minus 1 over 3 minus negative 2. That's 10 over 5 or 2. Now what?
Y minus.
Pick a point. Oh, let's take that one. Doesn't matter. Y minus the y equals 2x minus the 3. So y minus 11 equals 2x minus 6. Y equals 2x plus 5.
Yep.
All right, we'll pick up there tomorrow, or the next day. Guys, absolutely, you need to start studying on your own.